This video is on a proof of the fundamental theorem of algebra. The proof is very nice to visualize. Statement: every non-constant polynomial with complex coefficients has a complex root. Here we have taken a polynomial which is non-constant. We want to prove that this fx is equal to 0. If we take this equation, this has a root in complex number. We want to avoid the case when the constant term is 0, because then x is equal to 0 will be a trivial 0 of this polynomial. Therefore, a0 is not equal to 0. Now we can consider the polynomial function to be a function from this x complex plane to the y complex plane. We now capture the origin of y complex plane. This is because we want a pre-image of it to exist. For this, we want to take the images of the circles centering at the origin. They will be loops as the polynomial function is continuous. That is, if you take a point r theta and take the sequence r theta n such that theta n tends to 2 pi, then r e to the power I theta that tends to r e to the power I 2 pi, which is basically tending to r e to the power I0, which is r. And therefore the continuous image of r e to the power I theta n will be f of r. So the image of 0 and the limit of the points of r theta n, where theta n tends to 2 pi, are same. But we now want to know whether the loop is containing 0, or the origin of y complex plane inside it, that or not. Over here this origin is not contained, and over here this origin is contained. So which one will it look like? We want to know. Now for the time being, let us forget about the complicated fx, rather concentrate on f1x, which is simpler looking and which is equal to x to the power n, which is basically r to the power n e to the power I n theta. Now we make an observation that if our n is equal to 3, what happens to the x cube function? So if the point, the orange point over here moves around over here, this yellow point, the corresponding one, will move 3 rounds around this origin. And how will it look like? I'm trying to show. It will look like this, kind of. Now we notice another thing. If x is having a large absolute value, then fx is behaving like x to the power n. So basically x to the power n is the dominant term. And now if m is the maximum of the absolute values of the coefficients inside fx, and absolute value of x is greater or equal to 10 nm, and r, that is the absolute value, is very large in the sense it is greater than 1 at least, then fx minus x to the power n has the absolute value less than or equal to 1 over r power n. So here we understand that the difference between fx and x to the power n is bounded by a fixed quantity. Here is an observation that if this person who is walking on this trajectory of a circle is having a rope in his hand with which his dog is tied, and if the length of the rope is less than the radius of the circle, then how does the trajectory of the dog look like? So he will go in any kind of a trajectory, maybe it's different from the circle, but when one round is completed by the man, the dog also is completing one round. If this person is completing 2 rounds, the dog also is completing 2 rounds. So it will look something like this. Okay. Now for sufficiently large R, we have got that the difference between the corresponding image over here and over here, they are lying between 1 over 10 into r power n. So it is not, it when one round is completed over here, one round is also completed over here in some kind of a trajectory, and that is being repeated if there are more than one loops in this circle, right? So whenever this goes one round, this also goes one round. So how does it look? I'm trying to show. So this way. Also, notice in the previous one, we had the origin was contained inside the loop because it was covering um, the trajectory in some different way, but it was going around the circle. Now over here, if x is very the absolute value of x is very small, then it is kind of around a naught, which is the constant term, and a naught is not equal to 0, so it is far away from the origin, and around a naught or near a naught it will be a loop. Therefore we have two kinds of loop. One was around the origin and one was away from the origin. And when can it happen? It can happen, by the way, we should also notice how this looks like. So how does it happen? It happens only when there should be a loop around the origin which has crossed the origin once at least. So it was coming from here and then it has moved over here. So in between somewhere it has crossed the origin, and therefore this origin has a pre-image. We can see this from the video too. This one, this clip. So when this point was coming over here, if you take this point's position, maybe it was over here. So you can take the theta and also you have got the r. So basically you have got the pre-image. So I hope you like this proof. Let me know how you liked it. And this proof is from the book Algebra by Michael Artin.